Welcome to Geometry, Essential Standard 3, Learning Target 8B. Today we're going to do some Algebra 1 review where we talk about the equations of parallel lines and equations of perpendicular lines. So today should be a relatively easy day if you remember your Algebra 1 lessons. So we remember back in Algebra 1 we had two different equations of lines that we talked about. We talked about slope-intercept form, which was y equals mx plus b. M was the slope and b was the y-intercept. So we'd always start out by graphing the y-intercept, and then we would use the slope to graph points after that. And then we also had standard form. Standard form was ax plus by equals c, where a, b, and c were all integers. And from that form, we remember that we found the x-intercept to be c divided by a, and our y-intercept was c divided by b. And we would use those 2 points then to connect our line and draw our graph. So here in geometry, for a lot of the problems, we want you to go ahead and just convert it into slope-intercept form, because in Algebra 1 that seemed to be the easiest way for a lot of problems. So here we want to solve the equation for y. So our first step, we're going to subtract 2x from both sides because I'm trying to get y by itself. So we'd have 3y equals negative 2x plus 6 because I'm trying to get the x first and then the y-intercept. Our next step then would be to divide both sides by 3. So we'd end up with y equals negative 2x divided by 3 is just negative 2/3 x. And then I also have to take the 6 divided by 3 is 2. So there we see that the y-intercept would be 2 and the slope would be negative 2/3. So I would start off on the y-axis at 2, and from that point I would go down 2 and write 3. In the second problem, I've got the y has a negative 1/2 on it, but I'm not going to worry about that for the first step. First step is I'm to move the x to the other side, so I'm going to do that by subtracting. So we get negative 1/2 y equals negative 3x plus 4. Now our next step is to get y by itself, we're going to divide by negative 1/2. Now if you remember from Algebra 1, dividing by negative 1/2 is same as multiplying by the reciprocal. The reciprocal of negative 1/2 is negative 2. Remember, reciprocal just means to flip the fraction. So we would end up with y equals, so you can type it in on your calculator, take negative 3 divided by negative 1/2. So if we take negative 3 divided by, and do the alpha y equals, enter, and do negative 1/2, it shows us that the answer is 6, which is the same as taking negative 3 times by negative 2 over 1, and we would get 6 that way as well. So we would have 6x, and then I need to do the same thing with 4. That 4 divided by the fraction of negative 1/2 is going to give us negative 8. So we get y equals 6x minus 8. So we have a y-intercept of negative 8 and a slope of 6. Number 3 looks a little bit easier. We've got 2/3 y equals 4, so we can divide both sides by 2/3, or if you prefer, which I do, multiply both sides by 3 over 2, that we multiply by the reciprocal. That works just fine. If you don't like it that way, we need to take 4 divided by 2/3, and we get 6. You remember I said that I preferred to multiply by the reciprocal just because that's easier to do by hand, but I want to show you that it works on the calculator. We get 6 both ways. So we just get y equals 6. So remember that y equals a number, like y equals 6, would just be a horizontal line here through 6. So the slope is 0 and the y-intercept is 6. In other words, I could rewrite this as y equals 0x plus 6 would be the same equation. So now here on number 4, I'm going to start it off the same way. So I'm going to add 7x to both sides. So we get 3y equals 7x minus 12. And now I need to divide both sides by 3. Gives me y equals, well, 7 divided by 3 doesn't go evenly, so it's just 7/3. And we put an x behind it because it's 7 divided by 3 times x. And then 12 divided by 3 does go evenly 4 times. So our y-intercept is -4, and our slope is 7/3, meaning up 7, right 3. Now they want us to graph each line. So y equals 2x minus 3. I'm going to start off remembering that this is my x-axis. Sorry about that. X-axis and my y-axis. So my y-axis, I'm going to start out at -3. And I'm going to do a slope of 2, remembering that 2 as a fraction is 2 over 1. So I'm going to go up to right 1 and put a point. And I'll continue that going right up to right 1. Up to right 1 is the same as going down 2 and left 1. So I can continue that here off the graph. And now I'm ready to draw in my line. And that's the first graph. The second graph simply says y equals -4. So on my y-axis, I go down to -4. And all of these points, like this point here, is the point 2, -4. This point here is 7, -4. This point here is -9, -4. All of the y values are -4. So the equation of y equals -4 is simply a horizontal line through -4 on the y-axis. The third equation, x equals 3, well, on my x-axis I go to 3 and I put a point, and like this point here is 3, -2. This point up here is 3, 9. All of the x values are 3, so I simply want to graph a line that goes through an x-intercept of 3. And we would have that answer. And then the last one. The last one says 2y equals 4 parentheses x minus 2. So I need to get that into slope-intercept form to start out. So I'm going to distribute the 4. So 2y equals 4x minus 8. And then I'm going to divide both sides by 2. So this is just like we were doing on the last page. So we end up getting y equals 2x minus 4, that I took 2 into both parts. So I'm going to start out as a y-intercept of -4, and then do a slope of 2. So from here I'm going to go up to right 1, up to right 1, up to right 1, and continue that pattern off the page. And then I'm also going to go down to left 1 and put points. And now I'm ready to draw my line. And we can see that the first equation in red had a slope of 2, and the equation in black had a slope of 2. So that means that they were parallel lines, and we can confirm that from our graph. Write an equation of the line in slope-intercept form. So I see here that it tells us that the point 0,3, that's really a y-intercept, so that I know my b value is 3. And then I'm simply going to count my slope. From here, I am going down and right. I'm going down 4 and right 2. My slope is always rise over run. And since I'm falling down the hill, as I read from left to right, that's going to be a negative slope. So my slope is -2. So my equation is y equals -2x plus 3. Write the equation line passing through the points -1, 2, and 1, 4. So what two things do we need to know? Well, the first thing I need to know is my slope. and my slope is always y2 minus y1 over x2 minus x1. So if I label my points as x1, y1, and x2, y2, on top I'm going to subtract my y's, so I'm going to take 4 minus 2 on top, and on bottom I'm going to take 1 minus negative 1. So I end up with 2 over 2, which is a slope of 1. The other thing that I need to do is I need to find my y-intercept. My y-intercept is not an equation like the slope is. My y-intercept I find by using my slope-intercept equation of a line. So what I'm going to do, I'm going to write y equals mx plus b as my slope-intercept form, and I'm going to choose one of the two points. I'm going to choose the point 1, 4, because both of those values are positive, and it's just easier to use positive values. So I'm going to plug in 4 for y, and I'm going to plug in 1 for x. I also know that my m value is 1, so I'm going to plug in 1 for m. And now the only variable that's left is my b value, so I need to solve that for b. 1 times 1 naturally is 1, so then I subtract 1 from both sides, and we get a b value of 3. So my equation is y equals 1x plus 3. Remembering that you don't have to put that 1 if you didn't want to, that you could just write y equals x plus 3. So we know that all parallel lines have the same slope, but what do you know about their y-intercepts? Well, their y-intercepts, as you can tell from these two, this one has a y-intercept of 5, and this one here has a y-intercept of negative 2. So they will always have the same slope, but they will have different y-intercepts. What happens if they have the same y-intercept is that they become coinciding lines. Coinciding simply means that every point coincides with the other line, or they are the exact same lines. So they're no longer parallel because they are the same. So our equations will have the same slope, but different y-intercepts. So write an equation of a line that's parallel to another line, but through a given point. So the steps for this, so you can always come back to this screen. We want to find the slope, and then use the same slope in y equals mx plus b. And then a lot like how we were solving for b, I'm going to plug in for x and y and solve for b, and then write the new equation. That's our steps. So it's a lot like how we were doing our last problem. So let's do an example here. Write the equation line passing through the point 1, negative 1. So remember that's an x, y point on our graph, and is parallel to the line with the equation y equals 2x minus 1. So this is in slope-intercept form, so y equals mx plus b. So I can identify that my slope is 2. So now that I know my slope is 2, I'm going to plug in 2 for m, 1 for x, and negative 1 for y into my new equation. So y equals mx plus b. I'm going to plug in negative 1 for y. I'm going to plug in 2 for m. I'm going to plug in 1 for x. And now I need to find my new b value. Remember, our b value has to be different than negative 1, otherwise they would be coinciding. So 2 times 1 naturally is 2. So I'm going to subtract 2 from both sides to get b by itself. So we get our b value of negative 3. So our new equation, or our final answer, is y equals 2x, because my slope has to stay the same, minus 3. And we see that the slope is the same as our parallel line, but our y-intercept is different. For perpendicular lines, it is a lot of the same process, except for the slopes of perpendicular lines are not the same. They are opposite reciprocals of each other. After you find the slope of your perpendicular line, the rest of the process is the same. That we plug in for x and y, solve for b, and then we rewrite the equation. So let's do an example. Remember, you can always come back to those 5 steps anytime you get confused. So we identify here y equals mx plus b, that our slope is -3. So if my slope is -3, then my perpendicular slope, I don't know where that purple line came from, sorry guys. Then our perpendicular slope would need to take the reciprocal and do the opposite. So as a fraction, that's -3/1. So the reciprocal would be -1/3, but then I do the opposite of it, so it becomes +1/3. So that's the slope I'm going to use, is +1/3. Now I look back at the other information they gave us. They gave us a point x, y. So I'm going to plug in for x and y and 1/3 for m. So let's see here. Y equals mx plus b. I'm going to replace y with 2. My new slope is 1/3. My x value is 3. And I need to find what my b value is, so that way it passes through that point. So doing some quick math, 1/3 times 3 naturally is 1. So I'm going to subtract 1 from both sides to get b by itself. And I get b is 1. So now I'm going to rewrite my equation, plugging in my new slope of 1/3 and my b value of +1. And that's our equation of the line. Hoy-Vux is a thing that we use to remember horizontal and vertical lines. So the HOY, the H stands for horizontal. So if you think about a horizontal line, like here I'm going to graph y equals 6, that slope, it has a rise of 0 but a run of anything, so the O stands for 0 slope. And the y means that the equation of this line is y equals a number. So Hoy-Vux, the HOY simply means it's a horizontal line with 0 slope and y equals a number. The Vux, the V, stands for that it's a vertical line. So I'm going to graph that vertical line there real quick. So V stands for vertical. The U, my rise is any number, but my run is 0. And if I take a number divided by 0, I get an undefined answer. So my slope is undefined. And the x, so like this equation of this line here, is simply x equals -2. So the x means that the equation of the line is simply x equals a number. And so this is just a quick way to remember for horizontal and vertical lines, because they're just kind of special case scenarios. Write an equation of a line that is parallel to y equals 4. So let's start off by graphing y equals 4. So I go up to 4 on my y-axis and I draw a horizontal line, because Hoy-Vux, H-O-Y, so y equals a number, is a horizontal line. And then goes through the point 2, -4. So I'm going to graph the point 2, -4 here on my graph. In order to be parallel to it, it would have to be a horizontal line itself. So we can see that that's going through at -4 on the y-axis. So I simply write down y equals -4, and we're done with that problem. Write an equation of a line that is perpendicular to x equals -3. So let's graph x equals -3. So x equals -3, remember, is a vertical line here at -3, and goes through the point -1, 5. Well, perpendicular to a vertical line is a horizontal line, so that makes a right angle with it. So I've got a horizontal line, so horizontal HOY is y equals a number, and in my equation the y value is 5. So y equals 5 is my answer. So I would like for you to do these 10 problems as independent practice before you come up for your teacher talk. So please pause the video and do those 10 problems. Okay, welcome back. The answers to those 10 problems are here. Please make sure you show your work before you come up for your teacher talk. That's the end of our teacher talk. Please, or of our lesson. Please sign up for your teacher talk and continue the practice online. Thank you.